Okay, good evening everyone. Good evening, Misbah. Let's start. So just a second, let me set this up. Let's start. Good evening, Misbah. Okay, chalo. Yes, good evening, Akash. Hello, Ankit. Good evening, Sukanya. Chalo, let's start. Good evening, Shravani. We looked at binomial distribution today, and we saw that binomial is a discrete distribution, right? What happened? Discrete distribution. So we have seen properties of binomial distribution yesterday. Now let's see properties of Poisson distribution also, and then let's go to the questions together. Okay, so what we'll do is we'll see properties of Poisson also, and then together we'll go to questions of both. Okay. So next discrete distribution that we have to see is Poisson distribution. Just a second, there is some problem with comments here. So for binomial, we saw that Bernoulli's trials must be there. Okay, binomial distribution is made up of multiple Bernoulli's trials. Similarly, a Poisson distribution, I mean, if we want to apply Poisson distribution, then the conditions for Poisson model should be present, which are, okay, there are three main conditions which should be present so that we can use Poisson distribution. Let's see what conditions. Yes, Yashodan. Shubha Sandhya. Okay. Right. So the first condition is that, see, probability of success. Probability of success in a very small time interval. Very small time interval is constant. That is, probability of success is maybe like probability of finding success in an hour or in a day is constant. What does it mean? For example, if the time interval is, let's say, time interval t, hmm, of t period, t hours, t days, t years, or something like that, then the probability should be k into t. Okay, that is like, for example, if in 1 hour probability of success is fixed, or we know that it is very small, and then maybe on an average we get 3 successes in 1 hour maybe, then in 2 hours we must get 6 successes. Okay, that is the condition which should be present so that we can apply Poisson model. Okay, we'll see what this is, R, success and everything, but before that let's understand this process. Second condition that the model must satisfy is that probability of having more successes is very low. Okay, probability of having more or greater than one success in this very small time interval, is very low. Okay, so there are very less chances that we'll get more than one successes in a time interval. And third one is that probability of success in any particular time interval, is independent of earlier time interval. Okay, that means what? For example, if in this hour, okay, if in this hour we get 3 successes, then that will not affect next hour. Okay, next hour the probability will reset. It will be independent of this hour. Okay, so if these three conditions are getting satisfied, then we can use Poisson distribution. Generally, Poisson distribution can be used in cases like number of accidents on a particular street, in a particular month or in a particular day. Then maybe number of printing mistakes in a book, number of printing mistakes. Why? I'll tell you. Or maybe something like number of calls received. Hmm. Why so? Because the basic condition of Poisson distribution is that probability of getting more successes is very low. Now understand, number of accidents on any road, in any general road in a city, normal city, okay, lakhs of vehicles pass throughout the month. Out of that, there are only 5, 6, 10 accidents. Okay, so probability of accident is very low. Okay, 10 is not a low number on absolute basis, but out of 1 lakh vehicles, only 10 accidents is very low, right? Similarly, number of printing mistakes. In general, a book should not have ideally too much printing mistakes, right? Forget chapters like logical reasoning or matter essays in our book. Those have too many printing mistakes. But other than that, generally a book has on an average not much printing mistakes. Might be maybe 1, 2 or something like that. Or number of calls received in a particular hour, in a particular day, in a particular month, in a particular minute by a call center or maybe by you personally. So these processes follow Poisson distribution. This is where we can use it, apply it. Again, now Poisson is also a discrete distribution. That means, can anyone tell me its probability distribution or probability function is also called as what? Yesterday we have seen. For discrete distribution, probability function is called as what? Anyone? Probability mass function. PMF, right? Okay. So for Poisson distribution, let's say if X follows Poisson distribution with parameter M, there is only one parameter to this distribution, then probability that X will take a specific value is e raised to minus m into m raised to x upon x factorial. Correct probability mass function, e raised to minus m into m raised to x upon x factorial, where x can be from 0, 1, 2 up to infinity. 0, 1, 2 up to infinity. Number of accidents, ideally they can be up to infinity. Probability of getting 100 or 1000 accidents will be very low, but they can be up to infinity. Okay, infinity means very large number. Number of printing mistakes, number of calls, they can go to very large number, but generally they are only 0, 1, 2, 3 or on lower side, right? So this is PMF of Poisson distribution, where E is a constant having approximate value of 2.71828. This is not the exact value, this is an irrational number. Irrational numbers are non-recurring and non-terminating. Okay, so this E does not repeat or does not end, it is an irrational number. So we will take this approximate value for our calculations, 2.71828. Then M is the parameter of that distribution. M is average number of successes. Average number of successes may be based on our past experience or some analysis. And X is the number of successes for which we are calculating the probability. For example, let's say if we take a simple example like this, on a road, there are 3 accidents on an average. Why is it so bold? I don't know. Just a second. Don't know. On the road, there are 3 accidents on average. Fine. In a month. On the road, there are 3 accidents on average in a month. That means average number of accidents is 3. So if we want to model this using Poisson distribution, we have to take its parameter as 3. Okay, not perimeter. Parameter as 3. So based on this parameter, now if we want find probability of 2 accidents in a particular month. Find probability of 2 accidents in a particular month. So what we'll do is we want probability that x is equal to 2 successes. Success is accident in this case, right? So how we can solve it? E raised to minus m, that is minus 3, into 3 raised to x, that is 3 raised to 2, upon x factorial, that is 2 factorial. How will we calculate e raised to minus 3? E is 2.71828. Now understand, e raised to minus 3 is nothing but 1 upon e cube, right? So we'll calculate e cube first and then take reciprocal. How will we calculate e cube? 2.71828 into equal to, then reciprocal, then multiplied by 3 square 9 divided by 2. That should give you, can you even tell me what answer you are getting? The right answer. Anyone, what's the answer? Anyone? Correct, very good, Ishwaran. 0.2240, correct, Sanika? 0.2240 something is correct. Good. Correct, Akash. Rishraj, good. Check if everyone's got this. If yes, let's go to properties. Correct, Sukanya, good. Let's go to properties of Poisson distribution. Now we'll go through properties, then we'll go to questions of binomial and Poisson together. Okay, what different kind of questions can come? We'll just skip through solved examples. Fine. So properties of Poisson distribution. Now consider it very carefully. Like yesterday, first property is going to be same, that since it is a discrete distribution, it satisfies two properties. Which two properties? Summation of probability should be 1. Okay. Now that means summation of e raised to minus m into m raised to x upon x factorial should be 1. Now we cannot prove it right now. Yesterday I told you about binomial that we can prove it, but this on the basis of our syllabus we cannot prove it because we have to use something called as a Taylor series expansion for this. So that is not in our syllabus. But it's okay. For now just understand that this satisfies the condition, and probability that x is equal to x should be greater than or equal to 0. This we can check. E raised to minus m into m raised to x upon x factorial should be greater than or equal to 0. Now x factorial is obviously positive. E is positive, that means e raised to anything is also positive. And m is average number of successes. Now average number of successes obviously cannot be negative, right? So this is also positive. That means this condition is satisfied. Okay. So this first condition, just like binomial distribution, Poisson distribution also satisfies it. Then let's go to second property. Second property is that it is only one parameter, so it is called as uniparametric distribution. Just like binomial is called as biparametric distribution. The parameter is only m, which is average number of successes. And its mean is also very simple. Expected value of x, that is mu, is m, and its variance of x, that is sigma square, is also m. So that is why Poisson distribution is relatively simpler than binomial distribution from exam point of view, because to solve we don't have to remember much. Is everyone clear up to this point? Let me know once, yes or no, so that will go ahead. Let me know once if everyone is clear up to this point. Yes, no? Yes, good, clear, good. Okay, fine. Let's go to next property then, mode. Now mode is like binomial but simpler. Mode depends on value of m. We have to check if m is integer, just like binomial, m is integer or non-integer. And then we have to follow exactly same process. Let's take one example that x follows Poisson distribution with parameter 5. and X follows Poisson capital X follows Poisson distribution, let's say Y follows Poisson distribution with parameter 3.99. Now this is integer, this is non-integer. If it is integer, just like binomial, it is bimodal. What are the two modes? M is one mode and M minus 1 is another mode. That is, in this case, 5 will be a mode, 4 will be a mode. If it is non-integer, then it is unimodal. Rounded down integer value. Rounded down integer value of M is mode. Can you tell me what will be mode for this? Rounded down integer value. Rounded down. So what will be mode of this Y? Anyone? What will be mode of this Y? Anyone? Answer. 3. 3 is correct. Because even if it is 3.9999, you always have to round it down, never up. Okay. So 3 is the mode. Correct. 3. We can check it if we want. See. Just like yesterday's binomial, we can check it if the mode is actually coming to be 3. Let's take M is equal to 3.99 and check. Okay, M is also written as lambda, that is why this sign is there. Understand? Instead of M, sometimes this sign is also used, that is lambda sign. Okay, so let's say 3.99 if we take and if we calculate. See, mode is coming to be 3 and 4 is also looking similar, but it is smaller than 3. See, probability of 3 is 0.19585 and probability of 4 is 0.19536, so it is lower. 3 is the mode. Okay, 3 is the mode. Fine. Okay, then this was mode. Let's go to next property. Sorry. Sixth property that we'll see is, now understand, can you tell me for a Poisson distribution, will the shape of Poisson distribution generally be symmetric, positively skewed or negatively skewed? Anyone? Will the shape of Poisson distribution, if we graph it, will it be symmetric, positively skewed or negatively skewed? Based on this, can you tell me? Is it looking symmetric or positively skewed or negatively skewed? Anyone? Let's see if anyone can answer. Symmetric. Okay. Misbah would understand this X is not just going from 0, 1, 2, 3 up to 10 or something. For Poisson distribution, X will go up to infinity. Okay, X is going to go up to infinity. 0, 1, 2, 3, 4 up to infinity. So then tell me, does it look symmetric or is it skewed positively or negatively? See, you are looking at only this part of the graph which looks symmetric, but that X is actually going to go till infinity. Okay, the probability will be very low, but it will still go until infinity. So then tell me whether it is positively skewed, negatively skewed or symmetric. Anyone? Any idea? Positively skewed, that is correct. Let me know if everyone has understood this. Most of the values are here and then up to infinity there are very low values. That means this is positively skewed always. That means this distribution is always positively skewed. Has everyone understood why? And if yes, then tell me if you understand this statement. Tell me if you understand this statement. In Poisson distribution, correct, Ms. Puff. In Poisson distribution, probability of low successes will be high and probability of high successes will be low. Tell me if you understand this statement. Probability of low successes, that is probability that x will have very low values, 1, 2, 3, 4 will be high. But as we go towards right side, towards infinity, probability that we'll have 10 successes, 20 successes, 100 successes will be very low, right? Nearly zero. Tell me if everyone has understood this statement. Near these points 1, 2, 3, 4, or up to maybe some first few values, probability of success is very high. But as we go towards infinity, probability starts becoming low. That is why this is called as distribution of rare events. Distribution of rare events. Okay. Yes, got it. Okay. Let me know if anyone has any doubt up to this point. That is why this is called as distribution of rare events. Events which happen rarely. Okay. Fine. Let me know if anyone has any doubt. Otherwise, let's go to next one. No doubt. Okay, good. Approximating binomial distribution by Poisson distribution. Now this is important because this comes in some questions. See, understand what happens. As in binomial distribution, if in binomial distribution n starts increasing, okay, that is n starts going towards infinity and probability of success start going towards 0, then we can approximate this with Poisson. Okay, we can approximate this with Poisson distribution if n into p is finite. Okay, n into p should not become 0 or infinity, it should be something finite. 0 is okay, infinity it should not become. That is why in this case we can approximate it with Poisson distribution. For example, let's take a case of binomial distribution. X follows binomial distribution with parameters 200, 0.25, 200, 0.25. And let's say we have to find probability that x is equal to, that is number of successes is equal to 5. Okay. Now this will be very complicated to calculate manually. Understand, for binomial distribution it will be ncx, that is 200c5 into p raised to x into q raised to n minus x. 200 minus 5 is 195. Obviously this is difficult to calculate because we cannot raise this 195 times, it will take too much time, and 200c5 is okay. If it was something like 200c20 or 200c30, then we could not have calculated. It is not possible to calculate such value. In fact, 200c5 will be also very high. 200 into 199 into 198 into 197 into 196 divided by 120. That is a very high value. You cannot calculate it like this. Fine. But if we approximate it using Poisson, okay, first of all, let me tell you what this value is. Okay, we can do it on calculator, not our calculator. Okay, but I have an app which can calculate probability for large values. So let me calculate that and tell you what is this value. Just a second. Okay, and then we'll compare it with Poisson distribution. N is 200, P is 0.25, and X is 5. That is giving us answer as, no, it is very low. Okay, let me change it a bit. Just a second. Okay, no, we'll be able to do it in Excel. I'll do it. Okay, till then, let's approximate this. Till then, I'll do it side by side. Let's say X approximately follows Poisson distribution with parameter n into p. In this case, m is approximated as n into p because that is mean of both the distributions. Now n into p is 200 into 0.25. What is 200 into 0.25? Okay, in fact, instead of 0.25, let's take a very low value, even lower value. So it will be easier for us to calculate. Just a second. Instead of 0.25, let's take 0.02. This will be easier for us to calculate. So 200 into 0.02 is how much? 4. So now we can calculate probability that x is equal to 5 as e raised to minus m into m raised to x upon x factorial. This you can calculate. Can you try to calculate this? Till then, I'll tell you what is exact value of this. Someone tell me what is answer to Poisson. Till then, I'll tell you what is answer to binomial after doing it on Excel. That can be done easily. This answer is 0.035723. Someone tell me what is this answer. It should be very close. Anyone? E raised to minus 4 is 2.71828. Raised to 4 and reciprocal. Multiplied by 4 raised to 5. 4 raised to 5 means multiply by 4 5 times then. Divided by 120. No, we are getting something else. I think this was wrong. Let me check. Achha, 0.2. This was wrong. This is coming to be 0.157879 on Excel. Okay. Poisson value is coming to be 0.15629 something. Correct. So check if it is approximately matching. Is it approximately matching? Obviously that is not exact answer, but binomial distribution can be approximated by Poisson in such case when if n is high, p is low. Only then. Is everyone clear with this concept? Approximation. Because such questions are there in exam. If n is very high, 100, 200 something, then you have to use this. You cannot use binomial distribution. I mean, it is not possible to calculate on calculator in such case. Clear everyone? Yes or no? Tell me, then we'll go to last property of Poisson distribution. Correct, Akash? Yashodan, Sanika, correct. Correct, Sukanya. So in exam, in such cases, the answer will also be given as per Poisson. They will not give answer as per binomial in options because this is not possible to calculate. It will take too much time, so you don't have to do this. You have to approximate using Poisson compulsory. Last property, 8th one. Similar to binomial, additive property of Poisson distribution. Additive property. Similar to binomial. If x follows Poisson distribution with parameter m1, y follows Poisson distribution with parameter m2, then x plus y follows Poisson distribution with parameter m1 plus m2. Let's see through example like yesterday. Let's say x follows Poisson distribution with parameter 5, y follows Poisson distribution with parameter not 5, let me take a smaller number so that it will be easier for calculation 2, and let's say this is 3. Then can you calculate probability that x plus y will be less than equal to 2? Probability that x plus y will be less than equal to 2. How to do it? Concentrate. First of all, x plus y will follow Poisson distribution with parameter 2 plus 3, that is 5. Less than equal to 2 means it can be either 0 or it can be 1, or it can be 2. So let's add it. Now understand, whenever you solve a Poisson question, every term is going to contain e raised to minus m. So take e raised to minus m common at the beginning and then solve. M raised to x upon x factorial plus m raised to x upon x factorial plus m raised to x upon x factorial. That is e raised to minus 5 into 1 plus 5 plus 25 by 2, 12.5. That is e raised to minus 5 you can calculate on calculator, and then you have to multiply by 18.5, right? Correct. Calculated 2.71828 raised to 5 and reciprocal. Multiplied by 18.5. Check if everyone is getting answer as 1, 2, 4. Tell me. If yes, then we'll proceed. Let me know. Correct, Yashwaran. Okay, good. Akash, fine. Got it? Okay, good. Sanika, Vaibhavi, Sukanya, Misbah. So गई ना Misbah? Rishuraj is awake today. Good morning नहीं बोला Rishuraj. आज. Correct? Fine. Okay, fine. Let's go ahead then. Let's solve some questions from solved examples. The simple ones will not solve. And I have uploaded separate videos on this set C. Everyone must go through it because this set C covers nearly every concept from the chapter. Okay, this set C covers nearly every concept from the chapter. So go through those videos if you have any doubt in set C. They are separately uploaded. I think till 15 I have uploaded till now. 16 to 20 I'll upload tomorrow. So go through that. Let's go to separate question, like different questions on binomial and Poisson. So nahi gayi ho na? Okay. So let's solve only different types of questions on binomial and Poisson. Okay. Like this 17.1 will not solve. It is simple. 7.2 is simple. 3 is simple. Fourth one. Okay. Questions like this are very common. Questions like 17.4. Let's try it. You have to form an equation and solve. Let's see. Find probability of success for binomial distribution satisfying the following relation. 4 times probability that x is equal to 4 is equal to probability that x is equal to 2 and having parameter n as 6. Fine. They are saying that 4 times probability that x is equal to 4 is equal to probability that x is equal to 2, and they are given that this x follows binomial distribution with parameter n as 6 and p we don't know, p we have to find. Okay, fine. So I'll also do it on screen, you also try it, okay, those who know, otherwise concentrate here. So 4 times probability that x is equal to 4 is equal to probability that x is equal to 2, I guess, right? So let's try to solve this. 4 times, we know PMF of binomial distribution, n is 6, 6c4 into p raised to 4, p we don't know, into q raised to 6 minus 4, 2 is equal to nc2, that is 6c2, into p raised to 2 into q raised to 6 minus 2 4. Now if you remember combinations, 64 and 62 are same, so they should be cancelled directly. Don't do anything with that. Then this is p square. If we divide it here, then we can cancel it with p raised to 4. So if we cancel it, this p square will be cancelled and here only square will remain. Similarly, this q square will be cancelled and here only square will remain. So what is the remaining part? 4p square is equal to q square. Okay. That means 4p square, 4p square is equal to 1 minus p bracket square, because probability of failure is 1 minus probability of success. That means 4p square is equal to 1, this is a minus b bracket square, minus 2p plus p square. So if we rearrange 3p square plus 2p minus 1 is equal to 0, we can try to solve this. Minus b plus minus square root of b square minus 4ac upon 2a. So that is negative, we can ignore because negative probability is not going to be there. So minus 2 plus 4 plus 12 is 16, root 16 is 4 upon 6. 4 minus 2 is 2 by 6, that is 1 by 3. This should be probability of success. You have to be fast in solving equations, especially speed in solving quadratic equations is must. Okay. Solving quadratic equations is something that you should be very fast at because they come at many places, right? So clear everyone? These kind of questions are there in exercise, so you should go through them. Sometimes they ask some further question. Find 1.333 is correct, Mishpa. Sometimes they also ask some further question like now find probability of 5 success or something like that. That you can do. Fine. Okay. Tell me everyone if you've got it. If yes, we'll go ahead. We are just quickly going through the questions, so tell me if you don't understand something. I'll explain. These kind of questions are also popular, so let's go through them. 17.5. Tell me if you have understood the previous one. 17.5, let's read. Find binomial distribution for which mean and SD are 6 and 2 respectively. How to solve this? Mean is NP, which is given as 6. SD is root NPQ because variance is NPQ, right? That is given as 2. That means NPQ is 4. We have to find the binomial distribution means what? What is find the binomial distribution? Find binomial distribution means we have to find N and P for this. Now let me erase this root NPQ. Since we have NP and NPQ, that is very easy to solve, right? Because NP is 6. So let's put NP as 6. That means 6Q is equal to 4. That means Q is equal to 4 by 6. 4 by 6 is 2 by 3. If Q is 2 by 3, that means P is 1 by 3. And then we can put P here as 1 by 3. So N into 1 by 3 is equal to 6. That means N is equal to 6 into 3, 18. So the binomial distribution is 18, 1 by 3. Everyone, let me know once if you are with me till this point. Tell me once if you are with me till this point, then we'll go ahead. Because the fitting part is a bit complicated, fitting binomial distribution. So you have to concentrate 100% for that. Let me know if everyone is with me till this point. Yes, okay, good. Yes, fine. Okay, good. Others? If yes, then next part is fitting a binomial distribution. We use a method called as method of movements. Movements is the statistical values that we calculate, mean, variance, skewness or something that is not there in our syllabus, but these values are called as movements. Okay, so based on mean and variance mainly, we try to fit a binomial distribution to a given data. Let's not take example in module. Let's make our own example. Let's make our own example. Suppose we have x as 0, 1, 2, 3, 4. Frequencies as maybe 12, 14, let me take total, 24, 30, 20. So if you check summation f is 100. And the question is fit binomial distribution to given data. Now generally they don't, in exam they cannot ask you to fit a distribution. They will ask only a particular value. That is, they will ask what is expected frequency of this 1. Okay. What is expected frequency of this 3. So you have to calculate only that much. So let's see how to calculate that. So to fit a binomial distribution, we will use that mean of this data is x bar and mean of binomial distribution is np, right? So we'll set them as equal and try to find probability. Understand? Can someone tell me x bar of this data fast? X bar of this data fast. Check if you're getting 2.32. And since x is going from 0, 1, 2 up to 4, we can say that number of trials, if this is binomial distribution is applied to this, then number of trials will be 4, right? So then we can estimate probability, that is, we'll say that n into estimated value of probability, that is mean, is 2.32. Correct, good. N is 4, so 4 into p hat, estimated value of p hat is 2.32. That means p hat, that is estimated value of p, is 2.32 by 4, which is 0.58. Rishuraj 232. वैभवी के जैसा हो गया क्या? वापस. P hat should be 0.58. That means Q hat, that is estimated probability of failure, will be 0.42. That means this x approximately follows binomial distribution with parameters n as 4 and probability as 0.58. Tell me if everyone has understood this. And if yes, then what we have to do, fit this binomial distribution means what? We have to find probability that x is equal to x for each of the values. That is, for this one we'll find probability that x is equal to 0. For second one we'll find probability that x is equal to 1, 2 and so on. How will we find it? Probability that x is equal to 0 will be what? N is 4, so 4c0 into p raised to 0 into q raised to n minus 0, that is 4. Can you calculate this fast? Let's see how fast you can do it. Let's see whether I get it first or you get it first. Fast. Let's see who gets it first. May I up fast. Acha, Misbah, just like binomial distribution, this is number of successes. So probability that x equal to 1 will be 4c1 into p raised to 1 into q raised to n minus 1, that is 3. Then 4c2 into p raised to 2 into q raised to 2, 4 minus 2, 2, and so on. Understood, Misbah? Fast सानी का अब तक आना चाहिए था. Misbah, tell me if you have understood. Let me know when you get these values. I'm waiting. Aya, okay, good. Misbah got it? Okay, fine. Find the values. Others, let me know if you have got the values. Clear? Okay, good. Rishuraj Ala, okay, good. Yes, fine. Then we have to find expected frequency. That is, see, actual frequency of this data is 100, right? So if we try to fit binomial distribution to this, now I'm erasing this, then that means probability that x is equal to 0 we are getting as 0.031116, right? So probability is this much and total values are 100. That means expected value, that is expected frequency, will be what? Total value into probability. 100 into 0.031116, that is 3.1116. Then this will be 17.188. This will be 35.604. This will be 32.77. This will be 11.31. Total will obviously be 100. That is called as expected frequencies. What is the purpose of this? If this matches with the actual data, then we can say that, I mean, at least approximately matches, then we can say that this data follows binomial distribution, and then we can try to estimate values of this data using binomial distribution. Okay, then maybe for this data set, whatever it is, we don't know what this actually is, right? So based on that, maybe we can apply binomial distribution formula in real life to that data and find the values. So that is the purpose of this. Tell me if everyone is clear, because Poisson distribution questions will take tomorrow. Tell me if everyone is clear up to this point. Not fitting, correct? This is not fitting. I mean, it does not look like the values are similar. The trend is there, but not that much. So this binomial distribution is not getting properly fitted to this data. Clear, everyone? Can we stop? Tomorrow we'll take similar some questions on Poisson, and then we'll go to normal distribution. Normal has so many properties, a lot of properties are there in normal distribution, so don't forget about those. Clear? Okay, good. Fine, then let's stop for today. We'll meet tomorrow at same time with Poisson questions and normal distribution. Okay. If anyone has any doubt, let me know. Clear? Okay, good. Okay, then let's stop. Bye everyone. Yes, bye. Yes, good night. Bye.